Science and technology are a part of everyday life. For example, why is the ocean blue? Why is the sky blue? For the exact science behind these everyday observations led to the discovery of the Raman effect by Sir Chandrasekhar Venkata Raman, and also won him the Nobel Prize for Physics in 1930. Chandrasekhar Venkata Raman, or C.V. Raman, was born in Tiruchirappalli in South India in 1888 and was educated entirely in India. A brilliant student, he completed high school at the age of 11 years and received BA and MA degrees when he was 16 and 18 years of age respectively. His early studies were about the vibrations and sounds from stringed and percussion instruments such as violin, veena, tabla and mridangam. While studying for MA degree in physics at Presidency College Madras, he published 3 papers in the Philosophical Journal on unisymmetrical diffraction and surface tension. In 1907, after receiving MA degree, Raman joined the Indian Financial Civil Service as Assistant Accountant General in Calcutta in 1907. Soon, his deep interest in science brought him in contact with the Indian Association for the Cultivation of Science in Calcutta, which is an institute devoted to the pursuit of fundamental research in frontier disciplines of basic sciences. And Raman continued his research there after office hours in the evenings and on weekends. Raman was fascinated by the phenomenon of light scattering. Why is the ocean blue? Why is the sky blue? Lord Rayleigh earlier explained the color of the blue sky resulted from the scattering of sunlight by molecules in the air, and that color of the sea was just a reflection of the color of the sky. Not convinced by this explanation, Raman built a simple spectrograph and used sunlight as the source in his studies. Raman observed that the color of the sea was the result of scattering of sunlight by water molecules, not because of the reflection of the sky. Raman's first visit abroad was in 1921. Apparently, his research gained recognition internationally before he went abroad. Continuing the study of light scattering by liquids, Raman, assisted by K.S. Krishnan, discovered that most scattered light was at the same wavelength as that of incident light as per Rayleigh's scattering. And further, that a small part of the scattered light was at different wavelength or of different color. This is called the Raman effect. Less than 1 in a million of the scattered light particles or photons are at a different wavelength than that of the incident photons. Thus, the Raman effect is very feeble. The discovery of Raman effect soon became a significant tool for research and analysis in physics and chemistry, and Raman received the 1930 Nobel Prize in Physics. Raman effect was used to convincingly explain quantum theory. The character of the scattered radiations also gives valuable insight into the ultimate structure of the scattering substance, and soon opened a whole new world of applications. In the original experiments, Raman and Krishnan used concentrated sunlight and later mercury arc lamp as the light source. It was also observed that the nature of the scattered light was dependent on the sample of liquid used. In the present IEEE exhibit, which is a replica of the original Raman experiment, a green laser beam is used as the light source. Here, we see fluorescence, which is the emission of scattered light as per Rayleigh principle at the wavelength of the incident light. When a filter is used to isolate fluorescence, we see Raman spectra as wavelengths different from that of the incident radiation. In December 1998, the American Chemical Society presented a commemorating plaque to the Indian Association for the Cultivation of Science, acknowledging the discovery of Raman effect as an international historic chemical landmark for its role as an analytical and research tool and the range of its applications from the non-destructive identification of minerals to the early detection of life-threatening diseases. In September 2012, the Institute of Electrical and Electronics Engineers recognized the discovery of Raman effect as an IEEE milestone in electrical engineering and computing, which is a rare distinction given for a significant technical achievement that occurred at least 25 years ago in an area of technology represented in IEEE.